Okay, so our last part of this lesson is to find the net force of a given picture with four vectors acting upon it, four forces, and then find its equilibrium force, okay? Meaning the force that would balance out or cancel out the original forces, okay? The nice thing about the equilibrium force or the equivalent force is that it's going to just be the same magnitude, opposite direction of whatever you get for your net force. So when we're finding our F net, our net force, we're talking about a vector sum. So what I like to do is find the net force in the x direction first, then the net force in the y direction. So if you look at this picture, the x direction is your left and right. So I have negative 40 and a positive 40. All right, vector sum means we're taking into account direction. In this case, they cancel each other out. Since it's 0, you don't have a direction for it. In the y direction, that's up and down. I have 20 going up and 60 going down, so that's negative. My answer, we would normally write, right, is negative 40. But instead of writing negative 40, I'm going to write in terms of angles for my direction. And down is, as we know, 270 degrees. So now I want to find the overall net force. And this one's pretty simple. Since the x direction cancels out, our answer is 40 newtons, and the direction is 270 degrees. So what does that mean? That means with these forces acting on the object will end up going this way, down, for 40 newtons. That's the overall motion of the object. The equivalent force would then be the same magnitude, just opposite direction. And we know opposite of 270 is 90 degrees. So if I were to draw that, that's what it would look like. So far, pretty easy, okay? What happens when the x direction doesn't cancel out? What if it actually has a magnitude and direction other than 0? Great question. I knew you would ask. So let's do the same thing. Find the F net x and the F net y. Okay, I have a negative 70 and a positive 40 in the x direction, and a positive 20 and a negative 50 in the y direction. So my answer in terms of angles for direction is going to be 30 newtons at 180 degrees. And what that means is I'm going to end up going left for 30 and 30 newtons at 270 degrees, which means I'm going to end up going down. And when I draw my resultant or my overall net force, it's going to be like this. So when I find my actual F net, I'm going to use vector addition and find the hypotenuse. Okay? We use the Pythagorean theorem when we have a right triangle. In order to find the angle, our direction, because remember, vectors have both magnitude and direction, we're going to use the inverse tangent function. Now, some of you may recognize, oh, this is an isosceles triangle. I know that means that the angles are both 45, and I don't have to do the math. That's totally okay. Great for you. Okay, the rest of us, we just plug in the formula. So now I'm going to write my final answer for my net force. Okay, but I have to take into account that I'm in quadrant 3. We know in quadrant 3 we're going to add whatever we got for our angle to 180. So 42.4 newtons is my magnitude, and my direction is going to be 225 degrees. Now, let's talk about what my equilibrium force is. It's going to be the same magnitude, but opposite direction. Now, if I'm in quadrant 3 or quadrant 4, to find the opposite angle, I'm going to subtract 180. Okay? What that looks like on the picture is just like that. Okay? So, try the next two.